This is a pre-video for the fractional exponent section of 1.4. This is something we should have already started on for our timeline for last week. So just going to give you some basic terminology and a few basic examples of what we mean by fractional expressions. So a fractional expression is a quotient of two algebraic expressions. Normally it's two polynomials, and we say P over Q. We cannot have division by 0, so whatever you have in your denominator, you cannot equal 0. So for example, here's an example of a rational expression. This denominator would equal 0 if we put in either a positive or a negative 3 here. So we have to say that our domain, or what values are allowed to be plugged in, is any real number except for plus or minus 3. They can be more vague here. We don't really know what y or x are, but we know that if they were ever equal, it would cause a 0. So we'd say, we can use any x and y we want, so any ordered pair that we want, except that when we have our y, it can never equal x cubed. We'll be dealing more with the first type, where it's much more in single variable type of expression in terms of domain. So this is a property that you pretty much learn in grammar school when you do math and fractions for the first time. How do you reduce a fraction? Well, essentially, two numbers have something in common, and we break it down into the part that they have in common versus the part that they don't, and the part that they have in common is really a 1. So we never really say that. We say, you think about canceling out or reducing down a factor that they have in common. So a rational expression is considered to be simplified or reduced to lowest terms if the numerator and denominator have no common polynomial factors of positive degree and no integral factors greater than 1. So let's look at a very simple first example. This has no variables. It's pretty much just, do you remember how to subtract with fractions? I'm going to get my calculator out, because if your denominators are large, sometimes it helps to have your calculator to help you figure out what those are. For example, I don't know what 54 and 72 go into, but I know I don't want to multiply them by each other if I don't have to, because that will make my denominator really large. So one way to check is to just multiply the number that's bigger or smaller. It doesn't matter which one we start with first, but multiply by a couple things. So if we double that, that would make that 108. So I'm just going to list some multiples of 54. 54 times 1 is 54. 54 times 2 is 108. Add another 54 to that, or times it by 3. So let's just add another 54. That would be 162. And let's go one more, and then we'll do a couple of the 72s. Add another 54, and that's 216. If we list factors of 72, 72 times 1 is 72. 72 times 2 is 144. And we keep going until we find a match. We may have to list more of each. If you add 72 again, you actually get 216. Now, the reason this is nice is we can see the LCD, or the least common denominator, but we can also see how many multiples it took to get there. So we need to multiply 54 by 4 on both top and bottom to keep the fraction balanced. And we need to multiply 72 by 3, because it was the third variation of adding 72. So this would be 44 over 216 minus 21 over 216. And 44 minus 21, because once you have a common denominator, you add or subtract across the top, would be 23 over 216. And you would want to check to make sure that 23 and 216 have nothing in common. 23 is prime, and so unless 216 is divisible by 23, which I'm pretty sure it's not, double check though, yeah, it doesn't go evenly. So this is the reduced format of that rational number. Okay, let's do at least one more, maybe one with variables. So here's our rules. We're not going to do the adding and subtracting on the pre-video, because I find that that's something we should do in class, but let's talk about just simplifying a rational expression. You will factor both the numerator and the denominator into prime factors. That just means as far as you can. And then, assuming that nothing equals 0 in the denominator, we will cancel out common factors based on whether or not they're matching or not. So let's look at my A. So for a part down here on example 3, I first of all don't like the way they've got this. I always like to list my factors in descending order like we talked about in class. So that's negative r squared plus r plus 12 over r cubed plus 3r squared. Now top and bottom are both in descending order. We don't like to lead with a negative. That's something that I just always try to stress to students, that you don't want to lead with a negative. That does not help you for factoring. So if you pull that out, that would make this positive r squared, but everything else would change signs as well. And that will completely change how you factor that, because now this is not a positive 12, it's a negative. And then on the bottom, I'm going to go ahead and pull out my GCF of r squared. That would leave me with an r plus 3. On the top, I need factors of 12 that are different signs, because this is negative, and they make negative 1 when we add them. So it looks like it would be a minus 4 and a positive 3. And notice that we do have a matching binomial. You cannot just cross out a monomial with part of a binomial. It has to be an absolute match. So it looks like I have negative r minus 4 over r squared. And you're not allowed to cancel out the r with the r squared on bottom, because this is a binomial, this is a monomial. Okay, I think that actually gets us in a good place to pick up and start talking about this. In fact, I'm actually going to do one more. Let's just go ahead and do B. B is not much harder, but C and D are both addition, or subtraction, and those are a little bit tougher to deal with. If you're dividing, you just have to remember the rule that dividing by fractions means we multiply by the reciprocal. So I would fix that first. So now this is multiplying by the reciprocal of this second fraction. Things that factor. Well, the bottom, the easy part to see is this is a difference of 2 perfect squares. So that would be a plus 2 and a minus 2. The bottom on the other side is a monomial, so it's just going to be a. The problem is both of your tops are perfect cubes. So we need to factor both. This is a binomial times a trinomial, and another binomial times a trinomial. Cubed root of a is cubed is just a. Cubed root of 8 is 2, and we're going to keep a negative here because of the minus sign in the original. A times a is a squared. Change signs, so now we're plus. A times 2 is 2a, and always positive. 2 times 2 is 4. So this first top is a minus 2, a squared plus 2a plus 4. The interesting thing about perfect cubes is if the same numbers and letters are present, the factoring is exactly the same, except the negative is not in the first spot here anymore. It'll be in the middle, because this one has a positive originally. So I really don't need to do a lot of work for that one. None of the numbers are changing, it's just where the sign is. So the negative is now in front of the 2a instead of at the beginning. And by doing this, we see that the a plus 2's are going to cancel, because they are both on a top or a bottom, and this is multiplication. And then the a minus 2's are going to cancel. So we have this nasty trinomial times trinomial on top, and both of those are non-factorable. The perfect cube formula always gives you a non-factorable trinomial, and then over a. So this will be our final answer. You do not need to FOIL all that out. We leave it in factored form. So that would be it. Okay, so that leads us just with the adding and subtracting and some complex fractions to do for Monday, and then we can pick up with our radical discussion that we need to do. So make sure you watch all your videos. I'm going to post an announcement once everything's uploaded. We will have a worksheet in class on Monday when you first get in. Well, one of the examples will be from one of the videos, and the other one will be very similar. So I will see everybody on Monday morning or Monday afternoon, depending on which class you're in.